Imagine you step outside without an umbrella. The sky was just cloudy a moment ago, but suddenly it starts to rain. The first drops land on your arm, then your face. Within seconds, your shirt begins to darken. You look ahead at the building across the street. It's not that far, but it's not close either. And then the question hits you. The same one almost everyone has asked at least once. Is it better to run and get there faster, or walk so you don't hit as many raindrops? Which choice actually leaves you less soaked? Before we go further, make sure you subscribe to the channel and leave a like, because today we're breaking down a simple everyday mystery that almost everyone gets wrong. Here's the surprising truth. This question feels like it's about speed, but it's really about time, and a small mental trap pushes most people toward the wrong conclusion. Your intuition probably says this: if you run, you smash into more raindrops. You're moving faster, which means you're colliding with more water in front of you, so logically you should get wetter. If you walk slowly, you meet fewer drops head-on. That sounds reasonable. It feels scientific. But here's what most people completely overlook. The rain isn't only in front of you, it's falling from above. While you're standing still, deciding what to do, rain is already landing on your head and shoulders. While you're walking slowly, rain continues falling vertically onto you the entire time. So the real question isn't how many drops do I hit, the real question is how long am I exposed to falling water? Picture two versions of yourself. In one version, you walk calmly and reach the building in 2 minutes. In the other, you run and get there in 1 minute. During that entire time, rain is falling straight down. If you spend 2 minutes outside, you're exposed for twice as long as the person who ran, twice the time collecting water from above. Now, yes, when you run, you do encounter slightly more drops on the front of your body, but that increase is small compared to cutting your exposure time in half. Most of the water soaking your clothes isn't coming from what you collide with, it's coming from what falls directly onto you. This is where most people get confused. We imagine ourselves charging through a wall of rain, but in reality, rain is more like a constant shower pouring down. Whether you move fast or slow, gravity keeps delivering water from above, and gravity does not care about your walking speed. So already something interesting is happening. The common assumption that moving faster automatically means getting wetter starts to fall apart. Because if the dominant source of water is vertical rainfall, then reducing the time spent under it becomes the key factor. And here's what surprises most people. The difference between running and walking doesn't depend on how intense the rain feels. It depends on how long you stay under it. Even light rain will soak you if you remain outside long enough, and even heavy rain affects you less if you minimize your exposure time. But this raises a deeper question. Is it always better to run? Does physics clearly favor speed in every situation, or are there conditions where the opposite might be true? To answer that, we need to break the situation into something simpler. Instead of thinking about rain as a chaotic mess of drops, imagine two motions happening at the same time, raindrops falling downward and you moving horizontally. That's it. No drama, just two directions. And once you separate those directions, the logic becomes surprisingly clear. Because the real battle isn't between walking and running, it's between time and collision, and understanding which one dominates is what changes everything.
Let's simplify it even further. Think of the rain as a steady curtain of water falling straight down. If you stand still, that curtain keeps soaking you. If you move slowly, you stay under that curtain for longer. If you move quickly, you pass through it faster. Yes, moving forward means you encounter some additional drops with your chest and legs, but the amount of water coming from above over time is usually much greater than the small increase from forward motion. Time multiplies water. Speed reduces time. When scientists have modeled and tested this scenario, the pattern has been consistent. In typical rainfall, where drops fall mostly downward, moving faster generally results in getting less wet overall. Not perfectly dry, just measurably less wet, because less time under falling water means less accumulation. Here's where the mental trap becomes obvious. We tend to focus on what feels active. Running feels aggressive. It feels like you're attacking the rain, smashing into it. Walking feels passive and controlled. But physics doesn't care about feelings. Physics counts exposure. And here's another twist appears. There is a scenario where running doesn't help much or can even slightly backfire. That's when strong wind pushes the rain almost horizontally. Now the drops aren't just falling downward, they're flying toward you at an angle. In that case, increasing your forward speed increases the number of drops hitting the front of your body more significantly. The balance shifts. The advantage of reducing time becomes smaller. But in most everyday rain showers, gravity dominates. The rain falls primarily downward, and that means the clock is your real enemy. The longer you remain outside, the more water you collect. It's that simple. And here's the fascinating part. The difference between running and walking usually isn't dramatic. You won't arrive dry just because you sprinted, but you might arrive noticeably less soaked, enough to matter, enough to feel the difference in your clothes. This tiny everyday dilemma reveals something bigger. We often misjudge situations because we focus on what's visible and intuitive, instead of what's fundamental. We see ourselves moving through rain and assume movement is the problem, but the invisible factor, time, is doing most of the work. So next time you're caught in a sudden shower without an umbrella, you already know the smarter move. Running isn't panic, it's efficiency. It's minimizing exposure. Because the real goal isn't to avoid hitting raindrops, it's to spend as little time as possible under a sky that's pouring water on you. Small decisions hide quiet physics, and once you understand that logic, ordinary moments start to look different. If this explanation changed the way you think about something as simple as rain, leave a like, share it with someone who always walks in a storm, and subscribe for more ideas that reveal the hidden logic behind everyday life, because sometimes the simplest things hide the most misunderstood truths.